Good afternoon, everyone. Today we have our speaker, Dr. C. Valliyamma ma'am, along with us for session 3. Ma'am, thank you for your wonderful session 1. So this session will be about ecosystem tools for big data. Now I invite Dr. C. Valliyamma ma'am to handle the session, please.
Yes, thank you, sir. Morning, we had a session on introduction to data science. Now I'm going to give you a lecture on ecosystem tools. Okay, that's for big data. Okay, that's for Hadoop ecosystem tools. Able to view the screen?
Yes, ma'am.
Okay, ma'am. So the outline of the presentation, outline of this lecture goes like this: introduction to Hadoop, then HDFS, Hadoop distributed file system, then Hadoop ecosystem tools, and Hadoop installation. I don't know how many of you people having Ubuntu Linux platform. Okay, that's why I made it as a screenshot. I'll explain the screenshot and I'll share the PDF. Okay, installation guideline PDF. You can follow and later you can install and you can practice. First of all, introduction to Hadoop. So morning we had a session with introduction to data science. Okay, so there it's actually the big data science also is going to what? It's going to compute. Okay, that's a large volume of data only. So in big data, we are going to discuss about the Hadoop. Hadoop is actually batch processing. Hadoop is known as Apache Hadoop. It's an open source computing environment. The earlier version of Hadoop 1.0 is actually single-use system. It's only for batch processing. Okay, so now Hadoop 2.0, now 3.3 also came. 2.0 is batch auditing, this batch interactive online streaming all supported. Earlier that's all the Hadoop 1.0 is with the HDFS with MapReduce. 2.0 that's version with support with the YARN. Okay, so actually the resource management also done with the MapReduce itself, processing and the resource management with the MapReduce in the 1.0. Okay, it's a problem with the managing all the things and to make it as a multi-purpose system. Okay, the data processing and cluster resource management is divided into 2 layers. That's what it's a YARN. Okay, so YARN is yet another resource negotiator. Okay, the resource management done by YARN, data processing done by MapReduce. Okay, HDFS will do that, the highly available reliable storage. That means the distributed file system support with the HDFS. Okay, this is the architecture of the Hadoop. Okay, HDFS will be there, then YARN, MapReduce, and other ecosystem tools you can place here. Okay, you want to do processing on the data which is stored in HDFS. So component of the Hadoop, so applications run natively in Hadoop. Actually, it's a batch processing you can use with the MapReduce. Interactive thing you can the base and online HBase. Streaming you can do the Strong, and graph you can do the processing Giraffe. Okay, and in memory then you can do the Spark. And HPC-MP, the Open MPI. Okay, that's if you want, you can add any more ecosystem tools, Hive, HBase, Hive and Pig, Plume. Okay, this any ecosystem tools you can do it with respect to your need and with respect to the data process, what type of data processing you are doing. Okay, the four components for basic Hadoop framework is Hadoop Common. Okay, so that's nothing like the common libraries utilities used by Hadoop models. The next is the MapReduce. It executes a wide range of analytic functions, analyzing the data sets in parallel, okay, and reducing into results. Map is a function, map is a job, distributes a query to different nodes. Okay, map will distribute the task to a number of nodes and reduce gather the results. Okay, the nodes will compute the data. Okay, so now the reducer part gathers the result from the nodes and resolves them into a single value. That's the reducer part. So then HDFS is a default storage layer for the Hadoop. Yarn is present in version 2.0 but is not in 1.0. Okay, so it provides a cluster management actually. So Yarn will do that. If you add the Yarn, that's a 2.0 you install, you can run multiple applications on Hadoop. Okay, all applications will share the common cluster management. So first generation Hadoop, so we have to install, okay, separately, okay, because the batch processing, single application only can run. Here what we're doing is one application is HDFS again. Here you have that different applications on HDFS you can make it. So this means they're built for web scale batch applications, okay. So you want to make it as a, you want to run multiple applications on that shares the common resource management, then you can go with the Yarn, okay. So the Hadoop version 2. Okay, version 1, so the two main components, job tracker and task tracker. Here the job tracker will manage the cluster resources and schedule the jobs, perform the job scheduling. Okay, job tracker manage the cluster resources. For example, these are the 4 nodes added in cluster. Okay, these 3 are, for example, these are the head node, the compute nodes you make it. Okay, normal clustering what we do. Head node and compute node. The same here. Here the head node, here the compute nodes. Okay, like that. Okay, so here the cluster resources will be managed by the job tracker, and scheduling also will be done by the job tracker. And task tracker will be there on each node. Okay, that's what per node agent. Okay, so each node will be there will be one task tracker. Okay, the task tracker will manage the task. Okay, it won't schedule. The scheduler will done by the job scheduler, done by the job tracker. Okay, only the running of the task only by the task tracker. Okay. So limitation with the Hadoop one, lacks support for alternative. Everything needs to look like MapReduce. Okay, we should know that we cannot do that's iterating application MapReduce are 10 times slower. Okay. Instead of this, you can go with the cluster itself. Okay, so for that we are separating the data processing and resource. Okay, scalability. So here the scalability, maximum cluster size 5,000 nodes supports, maximum concurrent task only the 40,000 something. Okay, so availability here it is a failure kills queued and running jobs. Sometimes what will happen, we have to clean the jobs. Okay, running jobs, queued and running jobs whenever the failure occurs. Okay. So the secondary task, the hard partition of resource into map and reduce class. Okay, how we are going to convert? Okay, how we are going to make the resource into map and reduce class will be somewhat difficult. Okay, so the non-optimal resource utilization in Hadoop one. That difficulties. Okay, what are the difficulties earlier? Okay, so all limitations are sorted out in Hadoop 2 Yarn architecture. Here you're making that resource manager. Okay, resource manager, node manager, and application master. The 3 components in Hadoop 2. Resource manager will be the central agent which will manage and allocates the cluster resources. Cluster resources will be allocated here. Node will be in each node. Okay, this is a per node agent as like in Hadoop 1. It manages, enforces node resource allocations. Okay. Under the node manager, there will be name node and data node will be there. Okay. But the name node will be the node manager. Okay. Node manager run on name node. Okay. Data node only the actual data will be there. Okay. The metadata of will be stored in the node manager. Okay. That's what the name node. Here it is application master will be in per application. what are the applications you are running on Hadoop. Okay, so there'll be that many number of application masters will be there. So to manage the application, okay, and schedule the tasks. Okay. Okay, they're taking Hadoop beyond the batch because normally Hadoop supports the batch processing. Now we want to move to the streaming, like, okay, so you have to store all data in one place, have to interact with the data in multiple ways with predictable performance and quality of service. For example, here you see the applications run natively in Hadoop. Okay, you can run batch processing, or you can do with the streaming, or if you want to do any querying process with using HBase, you can do it. Okay, you want to do any stream, okay, in memory processing, you can go with the Spark. That is also possible. Okay, 5 key benefits of Yarn supported and improved cluster utilization because the cluster resource management is separated now. Scalability is good, and experimental agility and shared services. Okay, you can run multiple applications on single cluster resource management. Okay, using single Yarn. Fine. It's flexible, efficient, and shared. Okay, flexible because models beyond MapReduce. You can do this interactive and streaming also. It's efficient because it supports with the same hardware and quality of service provided and shared. Okay, that means that provides stable, reliable, secure foundation across multiple workloads. Fine. So here the cluster resource management is shared with all processing. Okay, all data processing engines. So the core components are Hadoop common. It's nothing like the libraries, common utilities to support the Hadoop models. First, it's high throughput access to application data. The distributor file system, it's nothing like the normal distributor file system. Okay, the same here it is. It's implemented in Hadoop. That is called as Hadoop distributor file system. Okay, we are going to run the application parallelly. Okay, Hadoop Yarn is a scheduling and cluster resource management. The MapReduce will do the parallel processing of large data sets. Okay, the HDFS instance may consist of thousands of server machines. You can add thousands of server machines, each storing part of file system's data. Okay, so large data sets and files. Here we are making the gigabytes to terabytes in size divided into blocks. Okay, so the block size is 128 MB. Okay, block size is 128 MB. So automatically your data is divided into blocks. Each block will be 128 MB. Okay, and the blocks are distributed across many machines at load time. Blocks are replicated across multiple machines known as data nodes. Already told that data nodes is actual data. The metadata of the data stored in name node. Okay, so the blocks are replicated across multiple machines known as data nodes. How the blocks are distributed? Each block will be 128 MB. Okay, that's how the master node, that's a name node, keeps track of which blocks make up your file and where the blocks are located. Okay, these information will be available in name node. Okay, to keep track. Okay, actually the data node will send the heartbeat messages. Okay, so here is the HDFS architecture. You see here name node, data nodes. Okay, under the name node, n number of data nodes will be added. Okay, so you can add n number of data nodes with respect to the size of your data. Okay, with respect to the number of MapReduce releases you have decided. Fine. So here the name node will be having metadata of the data and on which data node the data is replicated. These information will be available in name node. Okay. So the data node only the actual data will be there. Okay. The replication of data will be in other name node also, because some name node is fails. Okay. Your process should not be stopped. Okay, so what you can do, the replication available in another data node, you can start working from that. Okay, so for that purpose only how the replica is available. Okay, normally data nodes send heartbeat message to name node to confirm, okay, the data node is in working condition or not. Okay. Fine. As well as it will be sending the information to block replicas, where and all the blocks are available, where the host and the block replicas are available. Okay. The heartbeat message will be sent every 3 seconds will be sent, okay, by the data node. Okay. So the name node message from data node will be knowing that data node is alive. Okay, data processing is going on like that. Okay, any data node is not sending, that's what, any data node, any node is not receiving the heartbeats message or the signal. Okay, so automatically the where the replica of the particular data available in that in that data node, actual process will be continued. Okay, so name node is a main node. Okay, doesn't store actual data, it's only have the metadata. Okay, data node, only the actual data is stored. Okay, resource manager, node manager will be there. Okay, resource manager will allocate the resource. Node manager will be having interaction with the name node and data node. Okay. So the goal of HDFS, fault tolerance by detecting faults, by applying quick and automatic recovery, and data access via MapReduce streaming, simple and robust, processing logic close to the data rather than the data, portability across heterogeneous commodity hardware and operating systems. Okay, you can add a number of OS operating systems. It's portable, and scalability, reliability, stored and process the large volume of data, and the economy data and processing across clusters of commodity personal computers. Even you can add your personal computer as one more data node. Okay, so efficiency by distributing the data and logic, and here the data is processed in parallelly on nodes where actually data is located. Okay, so reliability is there because you have the multiple copies. That I already told that we have the replication. Okay, so the reliability is ensured. Okay, so automatically redeploying processing logic, and for example in any event failures. Okay, any data node fails, automatically redeployment will be happen. The process will not be stopped. Okay, it will be continuing. Okay. So there will be one backup node will be there in Hadoop. Okay, the backup node is act as a checkpoint node. Okay, it's capable of creating periodic checkpoints. Will be checking that up to date of the image file system of HDFS. File system of HDFS. That means that name node. Okay, the metadata of data node. Okay, data is stored in name node. Okay, so that image file will be stored in backup node. Okay, for example, if the name node fails also, okay, fine. Actually, the backup node will take up the work and it will send the messages to the data node. Okay, fine. That's the need of the backup node. It's also called as checkpoint node. Okay. So in HDFS, we are going to perform the. So what you do, you'll be writing the data on data node. Okay. Then while processing the data, you are going to read the data from the data node. Then you have to do the process using MapReduce. Okay. So the commonly used HDFS commands, mkdir, that's the main directory. I think many of you are familiar with the Unix commands. Okay. So then list, okay, ls for the list the files the given path, and cp for the copy the files from source to destination. Okay. So when you are going to do with the HDFS file system, then you have to use bin/HDFS dfs-mkdir path. Okay, so this should be used. Okay, so that's specified that you are working on distributor file system HDFS. Okay, Hadoop distributor file system. So you want to create the directory, you can create the directory as such how you are creating directory in normal Unix OS. You can make it. Okay. and you can get the whatever the process you are doing, you can get the output also. Okay, that's what's specified here. So you can create the directory, you can copy the output files from the distributor file system to the local file system and examine them. Okay, that's what you can get the output. Okay, that's stored in the, again, output as the actual data. Okay, that's again you can print. Okay, this mean, otherwise you can go to the browser also, you can go and go. Okay, so view the output files distributor file system, then you can do directly other this command, or you can do first get the output, then you can print the output. Okay, so data will be stored in output file. Okay, so you can to display the content of the output, you can make it this command. Okay, otherwise you can combine, you can do this bin slash -cat output slash star. Okay, so the next is the Hadoop ecosystem tools. Already told that HDFS is Hadoop distributor file system. Yarn, yet another resource negotiator. Okay, HDFS only doing what? Parallelly distributing the data and parallel processing it supports. Okay, distributing and processing. And Yarn, it's to the resource management. Okay, how it's going to manage the resources. And MapReduce perform data processing. Okay, using programming. You are going to do the data processing only through MapReduce. HDFS is only for to store your data. That means that writing. By write command, you can store your data. Using read command, you can get your data from HDFS. Okay. Then Spark, in-memory data processing you want, you can make with the Spark. Okay. You want to do any data processing services using query, and go with the pig hide. Want to support a NoSQL database. Okay. The data set. Okay. It's having what? Structured, unstructured, all type of data. Then you can go with the HBase. Okay, you want to support the machine learning models. Okay, machine learning algorithms. You have to import the Mahout, the Spark, MLlib. Okay, and you want to execute on SQL on Hadoop. It's supported the Apache drill. Okay, Zookeepers is very important to manage the cluster. Okay, Zookeeper should be there to manage your cluster. Then only the Yarn will work properly. Then OZ, this is also very important to schedule. Using these two only, Yarn will allocate the resources and schedule the jobs. Okay. Then Flume and Scoop. Okay, data ingesting. Okay, ingesting services. Here actually, Flume and Scoop. Okay. So directly, what are the generated data? Okay, for example, in Facebook and WhatsApp. Okay, so what are Facebook and WhatsApp generated data? Directly you can track and you can get it through Flume and Scoop. Okay. Then SOLR and using, okay, so searching for indexing can go, but usually you want to do with the pattern searching, you can use this tool. Okay, then Ambari is actually provision, monitor and maintain cluster. This is also default, you shall add it to monitor the resources and maintain the cluster. Okay, this is the Hadoop ecosystem tool, how it works. So first will be your, you can have your unstructured data with the Flume, unstructured, semi-structured data already to the Facebook, Twitter informations, okay, and Instagram, all these details you can use with the Flume, you can give the input, okay. So structured data, then you can go with the Scoop, okay. HDFS is mainly for storage. You can write the data on HDFS. You want to process the data, okay. You have to read the data and you have to process. You can go with the MapReduce, okay. You want to do the MapReduce task. You want to query the data, it's available on HDFS, then you can go with the HBase if there is a NoSQL database, okay. If you want, you can use scripting and you can extract the information, okay. Fine. To store the data, okay, and you can use a Hive, okay. You can use a Hive also, you can perform the SQL query. How you are querying using SQL, you can also use the Hive to retrieve information using SQL, okay. So analytical SQL on Hadoop, it's called as Hive and Drill, okay. Fine, Apache Hive and Drill, okay. So MapReduce for processing, data processing done as a mapper and using mapper and reducers. Okay. You want to support the in-memory processing, you can go with the Apache Spark. Okay. And you want to support the streaming data, then you can go with the Kafka and Storm. It's for the streaming data to process. Okay, to process streaming data. The machine learning libraries you can include using Mahout or Spark MLlib. Okay, Mahout can go with the normal Apache Hadoop. Okay, doing with the Spark, then you can go with the Spark MLlib. Okay, Zookeeper and Ambari, it's very important. This should be available with all. Okay, Hadoop setup that's there to manage cluster management and job scheduling and monitor the cluster. So the big data technology, this is what are the terms we have discussed, put it here as have been given here. I have put all the terms, okay, we discussed. Okay. Whatever the data is getting out of the big data analytics. Yes. MATLAB. Or you can go with the Hive and Mahout for the machine learning libraries. Otherwise, you have to make it the MATLAB for the image processing like that. You can go with the MATLAB. Even the OpenCV supported with the Hadoop. Okay. And deep insight. Okay. This means that you can apply any machine learning algorithms. Okay. Supervised learning, social media analytics, sentiment analysis, predictive analysis. Okay. Network analysis, visualization, business intelligence. Okay. And visualization you can do. Okay, the tools. Okay, you can go with that. Fine. In big data, that's why you are going to process the data in terms of zettabytes. Okay, nowadays the data in terms of yottabytes, you are going to store on Hadoop. Okay, HDFS. So tips for designing big data solutions. You have to understand the users and resources. That's the sources. Okay, that's from where you are getting the data. Source of data. Okay, and discover the architecture driver. Okay, that means that you are going to work on structured data or unstructured data. Okay, or you want to be working on streaming data, or you want to do only the parallel processing. You want to do only parallel processing, you can go with the MapReduce. Okay, if you are going to store and retrieve, extract information, you can go with the through scripting means you can go with the pig. Okay, you want to retrieve information using SQL means you can go with the Hive. Okay, so NoSQL means you can go with the HBase. Okay, that's what we have discussed. Okay, NoSQL you can go with the HBase. That's for an unstructured, structured, semi-structured, all type of data you can go NoSQL database, HBase. SQL means you can do the Hive. Scripting, through scripting you are going to extract information, you can go for the pig. Okay, to support the machine learning models and algorithms, you can go with the Mahout. Okay, or the Spark MLlib. So you have to choose and discover that architecture driver. Select proper reference architecture. Okay, all the time you need not all the ecosystem tools. Okay, depends on the application, depends on the need. You have to choose the tools. Okay, to import the data and to export your data. Okay, do trade-off analysis, address the cons, and how to resolve the cons. Okay, you have to look for. Then map the reference architecture to technology stack and prototype your work. Okay, re-evaluate your architecture. If there is any change, you can change it. Set up DevOps. So that means the development operations practices from the beginning. Okay. Hard research directions with respect to big data. Morning itself we discussed fraud detection, market analysis, and classifying the fake users. Okay, to want to identify the on Facebook. Then what you have to do? You have to get the Facebook profiles. Okay, extract the Facebook, store it on Hadoop or the Spark. Okay, how to apply some machine learning models to classify the fake users and classify insincere posts. Because it's very important for the topic modeling. Okay, few people simply they post informations. Okay, and there's modeling. We need the data that is the particular topic is discussed, okay, for in particular duration, okay, and spam email detection and recommendation systems. That's already told that the topic modeling here comes. Recommendation engines and sentiment analysis for Twitter and review on conversations, okay, and customer relationship predictions, even with the Amazon, okay, Flipkart, they'll be using the customer relationship predictions and geographical data visualization, okay. So the geographical GPS, geopast data you want to add, you can go with the geographical data visualization, okay. The tool is GeoParse API is available. Using that, you can do with the geographical data visualization. Okay. For example, any disaster occurs that you are getting through the tweeters, okay, tweets from Twitter data, you are going to identify the disaster. Okay, disaster event occurs. Then what you do? You have to collect the tweets, and from the tweets you have to get the hashtags. Through the hashtags, they are what type of disaster they are discussing. This means a flood or cyclone, or they are discussing about landslides or earthquake. Okay, according to the hashtags, you can group the tweets. Okay, and you can identify where the actual disaster occurs. Okay, and what type of help. Okay, you have to provide to the particular location. That you can do with the geographical data visualization. Okay, so next we are going to do with the installation part. This is a Unix directory structure. I think many of you well known to the Unix directory structure. Okay, in Unix directory, all files. Okay, this was the directory also a file. Okay, I think remember root direct under root will be having boot user etc. Under user only bin, because we are going to deploy HDFS in the bin, okay, and lib, okay, share include. So this include will be using in the C programming and all, okay, and etc. Then home directory and devices with the device, okay, and you have your, that's enough, okay. So we are going to use this part only, fine. Unix system files /etc/profile. There only are going to set the environment variables to start up the bash shell. Okay. Modify the kernel parameters at runtime using sysctl.conf. This file you have to open, you have to change the parameters. Okay, we'll discuss. The frequently used commands are ls to list the files, sudo to execute the command with root permissions, and cat to display the output. Okay, let's read one or more files. Okay, if you're reading means you have to make use of this arrow. Okay, this was then simply cat will give that file, then you can make use of the, you can display the contents of the file. Okay, chown, that means that change the owner of the file. Okay, chmod, change the access is a command. Okay, we're making that 77 to workspace. You are giving all permission. That means that actually 4 for reading, 2 for writing, 1 for execution. Okay, so you are giving what? 4, 2, 1. So you add that, you will get 7. So you are giving for all the users. Okay, admin, user, all other users, you are giving 7. Okay, all users to execute permission. Okay, read, write, execute permission you are giving. That's why you are giving the 777 to the workspace what you created. Okay, on the so you can use any editors, you can use VI or Vim or gedit, Nano or Emacs. Better to use a gedit. Okay, so it will be user friendly. Want to explore more knowledge to these books. Okay, so very good books to explore more on big data with Hadoop. So questions? Thank you. Any questions?
Professor, can you show us the book list book?
What's up?
A book list you have shown.
Yeah. Yes.
So Hadoop is covered in all the book or one, two?
No, no. Hadoop is covered in two.
Okay, okay,
Okay.
okay.
The Hadoop in action, Hadoop definitely only.
Rest all for the theory to understand.
Yes.
Thank you.
Yeah. Any doubts? புரியுது சொல்றேன். Chatting எப்படி remove பண்றதுங்க? Stop பண்ணிட்டேங்க. Okay. Stop பண்ணிட்டேங்க. அங்கே stop பண்ணுங்க. ஆமாங்க. அண்ணாவுக்காக நான் Yes, ma'am.
Yeah, you are going to share the screen now, right?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Few minutes, ma'am.
Okay, fine. Okay.
I'll share. Able to view the screen?
Yeah.
Yeah. So now we are going to discuss about single node configuration for Hadoop on Ubuntu. I will tell the steps to configure the Hadoop on Ubuntu. So prerequisite is you should have the JDK. First you check JDK version. Okay, which version you have. Better to have JDK latest versions. Okay. Single node configuration, you have to make it as your master and slave on same node. Okay. First you have to create a dedicated user account for Hadoop. So for that, what you have to do? How to add, okay, sudo add group Hadoop. Okay, now we are creating a group, name is Hadoop. In that, we are going to add username is SD user. Username is SD user. Okay, then you are getting the SD user. Now we are getting inside to the SD user login. Okay, wait, we'll see it's able to view the screen. Tanishri ma'am.
Yes, we are able to see your screen, but the letters are not clear. Can you zoom it a bit?
Okay now? It's
So
okay
what?
now?
Yeah, it's okay.
So now what we are doing here, now we are adding the group, okay, Hadoop. And for the in the group, we are adding the user, okay, fine. So initially it is telling that there is no user, now the user is created, okay. The user is created, then you create the key generation, you have to do it. It's a normal procedure to create the user, okay, that's it. It's a key gen, SSH key gen, okay. This for the generating public private RSA key pair should be generated, okay, to verify the user. So that's what the key gen generate private and public key pair at terminal using SSH key gen. Okay. So here we have generated the key gen. You can see that key is generated. Okay. To enable the SSH, okay, secure shell to local machine. Okay. You have to, you can give the cat command, then you can see this, okay, you can type this, you can view the authorized keys, you can easily, you can view, wait a minute, field zone, cat, the same command I have typed, okay, cat $home.sh, okay, this is for share the secured key, okay, so see here, authorized keys, that means that authorized keys are shared between, okay, the users. Then you give the local host. So to check the secure shell installation is completely done or not. Okay. One second. Okay, then you have to, already told that you have to give the permission. Okay, all read, write, execute permissions to the user who are working on the local directory. Okay, then you extract the file Hadoop. Okay, that's what extract the file and start the installation path. Install the Hadoop. Okay, install Java 1.8 first and install the Hadoop. Okay. So for that you give permission. Okay. So change chmod 777. That means that all permissions are giving to this Hadoop. Or to install the software, then set the Hadoop environment variables. Okay. In the ./rc file. Okay, you type $home/./bash/rc. Then we have to type these commands. Export. Okay. Suppose is already there, not needed. Sometimes what like here, this one you have to give it. Sometimes already the Java is already exported, no need to give it. If the Java is newly downloaded and doing means we have to export the Java. Okay, that's what home path you have to set it. Okay. Then we have to set the alias. And you give that bin directory to path. Okay. So the Hadoop, add Hadoop to bin directory. Okay. So Hadoop you installed in local. Okay. That's now we move to bin directory. So then set the Hadoop environment variables. Okay. So you can set the environment variables. You can check it. Java home, you can check it. Hadoop prefix, you can check it. You can check the correct version of the Java is installed and Hadoop is installed. You can check it. Otherwise, you can set the Hadoop environment variables using /etc/profile file. /etc/profile gedit, you give it /etc/profile. Then you go and give all these commands. Okay. Then run the bash rc and profile files in the $prompt. So already I have set the environment variables in bash rc file, as well as I have done with the etc profile. Okay. So I have to run to set the two environment variables. To set the environment variable, you have to run the command. Then only the environment variable will set. Okay. To verify, you can run Java version will give 1.8.0_25. Okay, then you give the echo $Hadoop prefix, it will be giving the Hadoop version 2.5.1 like that, we display. And you give the Hadoop version, it will give only the version. Okay. Then you have to configure the Hadoop files. Okay, Hadoop-env.sh will be automatically will be created, will be there. Then core site.map spread site XML and HDFS and yarn site XML. Okay. So the path to the local directory, you can go with this. You can get the files, then the shell script. Okay. This env.shell script you have to create, include the following lines. Okay. In this shell script you have to include these lines, and you take this XML.xml 4-site XML. How to include this file, because you are going to store data files. Okay, that's by the Hadoop distributed file system on single machine. Okay, fine. Then you have to set up the default host with the port number 9000, because you can run the HDFS from the browser also. For that you are setting this lines, you are setting this property. And you want to add the MapReduce functions, you can make it with the MapReduce functions to the sudo. Okay, that's what the XML to .template to this site. Okay, you can make it. Okay. Then you have to make use of the HDFS replication. You want to make it. Again, you have to create the DFS.replication. Type all these. You have to type. All these you have to type in the file. Okay. Don't change the name of the file. Don't change. Don't do the copy paste. Okay, it will give error, because the copy paste it won't give some blank space will be added in Ubuntu. That's a Unix platform. Will give error. Okay, you couldn't be able to rectify the error. Okay, so we cannot be able to identify what is the error. So better you type. Okay, then setting up the yarn. Okay, for the services, resource management and job scheduling services, and you want to add the MapReduce with the shuffle. Okay. Then now the Hadoop file system is implemented on top of local file system. We are going to implement. Okay. So what will happen now? We are giving name node -format. Okay. So now we go and see how it is done. See, I'm jar file installing, so it will extract the file. Okay, so then I'm checking local host, it's working correctly or not. SHX local host. Then you see here bin, okay, start all.sh, okay, this you can make it. This mainly for to set up the yarn. So sometimes it will ask for the password, then you have to type the password. If you are working in the root, no need. If you created the SDU, another user you created, then you have to give the password. Okay. So C source dot bash rc. There I have opened the source, I have added the lines. Okay. I set the environment variables for Java and Hadoop. The same I set the environment variables in etc/profile also. Then after setting this, if I type the Java version, I will be getting this. So by running this, you can able to set the environment variables. To set the environment variables, you can make the gedit dot bash rc. You can go and type the lines. The export command, you can write it and you can set the environment variables. So come out from the loop once again. See, I have given the so this was Java version. Java version give 1.8 okay, 1.8.0 25. Okay, if you want to know the Hadoop version, you can give it the same. So already given that Hadoop version, it will give. So now it started installing the name node, data node. See here, name node is there. Okay, name node, data node, everything is created. Okay, now I have to set up the permission for all. So sudo chmod 777/user/local. So I'm giving permission to all users to access the file. Okay, so the to the SD user and giving all permissions. So now it will be name node is created. See, starting name node is started now. Then you sbin/start-all.sh. Okay, it will execute all the shells. Okay, this we have created Hadoop environment sh, 4-site XML, MapReduce. Okay, this is all shells. Okay, shell scripts will be executed. sbin/start-all.sh. See, it will be asking that you want to continue connecting. Okay, permanently you're creating. Okay, so they will be asking for the password. You type the password. It will be starting. See here, start. Okay, main node is started, and secondary name node is started. Here the name node is started. secondary name node is started. Same command only, okay, but it's I've taken separate screenshot, okay. See, then yarn created secondary name node and started yarn daemons. See here, and resource manager is running. Okay, yarn daemon started, then automatically resource manager is running. Okay, in Hadoop version 2, resource manager, node manager. Doing the resource allocation. And also the job scheduling. Okay, so that's all. The installation is over. You type /sbin. Okay, so you type the /sbin/start. Here one space should come. Hyphen all, then sh. Okay, no space, no need of space. Okay, hyphen. Here it is hyphen all sh. Then the Hadoop. Okay, explore the Hadoop. Okay, which you can make it with the Hadoop will be installed. Starting its installation. After its first name node is created, then secondary name node is created, then data node is created, then resource manager, then node manager. Okay, then you put after JPS, the command prompt will come. Then you put JPS. You see here, resource manager is created, name node is created, secondary name node is created, data node is created, node manager. All these 5, okay, resource manager, name node, secondary name node, data node, node manager, all 5 should come. Then only your installation is correct. So now you want to open the Hadoop file system on browser means just you type, okay. Here it is the FTP:/localhost. Some port number you from the browser, what number you are given in the file. Okay, so earlier you are given. Okay, the same you have to give it. Here's some change. So it will be showing, okay, localhost 9000 because I create a localhost 9000. Okay, started. So what is the version? What is the compile? What is the cluster ID? Okay, it's given. Summary is also given. Okay, configure capacity, data file storage. Okay, distributed file storage used, how much used, it's given. What is the heap memory? What is the maximum heap memory? Everything will be, you can view from the browser itself. How to go to the browser, automatically you type http://localhost. This one you can make it. Okay, you want to make it the DFS, that will be in different port. Okay, 50070. Hadoop running on here. Okay, so here the port number is changing. Okay, so the change in the file it is different port number. Okay, so make it change. So you want to know the name node information, and go to the utilities, browser file system, and browse the directory. Here I didn't create any files. Then now I want to put, okay. So you go and see the slash output, it will be giving the owner is SD user. Fine, one replication is available, but there's no data. That's okay. Then you come and you can go on view input. Okay, so you make the directory. See here, cd bin hdfs dfs -make directory input. I have created directory on is distributed file system directory name is input. Okay. So you create the directory input. Fine. Then I can upload sample data, okay, to HDFS. Okay. So sample data. The sample data will be uploaded. So using so we can go and click open, you can do it, it's not an issue. So automatically it will be adding the files, the jar file. I added as a jar file. Fine. One second. I have to start executing the listen. So I created the HDFS, DFS, MKDR input. I created one directory input. Okay. Fine. So there I am downloads the sample data. I have downloaded what? 5 files. 1, 2, 3, 4, 5 files. So from the 5 files I am going to do some process. I'm going to do some process. Okay, here the process, the files are having Hadoop code I have written, the MapReduce code. The MapReduce code I added that. So simply that CSE, the students, okay, how many students are in CSE, how many students are in EC, like that is right. So that file, that is available in file 2 and file 5. Okay, here the CSE 1, CSE 2, like that. Okay, ECE 1, ECE 2, the same, like that information will be there. Total count of CSE, total count of ECE. Okay, that will be identified. So the automatically you are you are running this jar file. So mapper reducer will be executing, and your yarn will allocate the resource. Jobs will be scheduled. See here, connecting to resource manager. Job will be submitted. Yarn will execute the, okay, yarn will allocate the resource. So it's now the MapReducer code is being executed. That's what I'm saying, number of bytes written, read. Okay, this is all the MapReduce code execution. So $Hadoop prefix. Okay, then I want to, here it is processed, data will be in output. Okay, that output file should be, I have to make it in browser. Okay, so what I'm doing now, Hadoop prefix, making the put. I'm taking the sample data to HDFS. This command, what's it doing? I'm putting the all 5 files, file 1, file 2, file 3, file 4, file 5. Okay, this all 5 files I made as a zip file. That whole zip file is down. I'm going to write it on HDFS. For the command is put. I'm going to put the file in distributor file system. The files are file 1, file 2, file 3, file 4, file 5. Okay, fine. So then you make it as that will be act as an input. So you go and see the browse directory, you can go and explore, you can identify that input will be there, output will be there, and temporary, okay, and user, normally what it's already created, the user directory and temporary directory, and you have the input and output. Now there is no data in output. Okay, now I have added the input. Okay, so it will be giving the, go and click the output directory there. one more file is created, part-rr00, because successfully executed the MapReduce code, and it's making that CSE keyword as CSE word as 453 times. This occurs in the on the code file 152, 53, 54, 55. Okay. So actually file 1, file 2, all the files will be distributed on different nodes, and on each data node, the count of CSE keyword is computed, and the count will be added in reducer part, the key value part will be added and given the final result. Okay, this was the CSE, the 453 times it occurs in the files, the sample data. Okay, it consists of 5 files. In the 5 files, the CSE occurs 453 times. Okay, so that's all the installation part. So already told that to put the input, you have to make the directory /input. Then the sample data, if it is in zip, you make it as a tar file, then put it in the distributor file system. Okay, using put command. Okay. Then you are executing the MapReduce. See here, /b/hadoop jar hadoop MapReduce. I'm going to execute the MapReduce code. Okay, grab the input is the input file, output I need a for only for the keyword CSE. For the string, the CSE how many times occurs in the files. Then you are getting to write the files to DFS, you have to use put. To get the output, make it the -get. Okay, then you put cat output star, it will be printing CSE. Otherwise, you can see the output in the browser itself. Browser itself, you go and keep the output directory. There, one file, part file will be created. That part file will be having the output. Any doubts? That's all the installation of the single node. Give an example for executing one time CSE word has occurred. Simple word count program. Any doubts?
No, ma'am, you can proceed.
One to the hive.
Vali ma'am. Yeah, most of the participants, right, they are asking for this Word document as well as your PPT. Okay, yes. So you please send it to me through mail so that I can forward the same.
Yes, ma'am. Yes, ma'am.
For the PPT and this Word document.
Yes, ma'am. Yes, ma'am. I'll send it. So now we can see how can you install the Hive, and putting on the data.
Please zoom it further. You're not able to see the screen. Yes. I mean, yeah, fine. Fine, ma'am.
Yeah. So now we are going to discuss about Hive installation. After installing the Hadoop. Above the Hadoop, you can install Hive. You want to work, you want to query, okay? So you want to extract few information that is already stored on file system. That's what normal SQL same we can do with the Hive. So you have to download the Hive latest version from the official website. The tar file will be there, then you have to extract. Once the extraction is completed, then as usual you have to go to the bash RC file and set the environment variables for that. Okay, so I given the Hive home. Okay, this is what environment variable I have set for the Hive. I'm setting this path to the set it, then export the path. So if I check the source, execute this, now the environment variable will be set for the Hive. Okay, the Hive command can be used to check if the installation was successful. Okay, so here I have to give the permission to all the users. Okay, groups, users, owners, everyone. So making that the 777 to whole folder. Then I'm changing drive to the Hive home. Okay, it's already I have set the path to the home directory. Okay, then you make it, if you give automatically go to this path, then you give bin/hive, then automatically one window will come. There you have to type it. Okay, the command prompt will come. Okay, this is for understanding purpose I given the command. Okay, so Hive, here the command prompt will come. Here I created the table, create external table survey. Okay, name string, age integer, place string. Okay, then choice string. Now I'm storing the data in terms of row format, that's why the row format. And delimit each fields by comma. Okay, so stored as a text file location Hive/survey. This is what I'll give it. So automatically this whatever you are giving data table will be created, will be stored. Okay, the show tables, if you show all the tables in with y, then show tables dot star dot y. Okay, so you want to detail, okay, information about the table, you can specify the description about the how you are using in Oracle. Okay, DSC, describe the schema. The same here, DSC survey, it will give what are the fields you made it. Okay, you have created with respect to the table. Okay, will be showing. Then you have to make the local path override to the table survey. Then you can make it select count start from survey means, okay, it will display the number of rows in the table survey. How we are using SQL, okay, select start from table. The same, select count start from survey. Survey here is table. I create a table here, survey. Okay, so how you are doing SQL query, the same you can do it here. I want to see, select start from survey where choice is ECE. Okay, and name like LAI. Then display the terms. Otherwise, I remove this to make it the choice ECE means it will display the tuples where the choice is ECE. That's mean that name and age and place and person name, person age, person place and person choice. Everything will be displayed. Okay, so store the HiveQL result back to local HDFL file system. So what you have to do, you have to insert override local directory. OPT, this is the command you have to use. CSV file. CSV file format you have to add. Okay, because the delimiter is comma. Already while creating the table itself, made it as a delimiter is comma. So I'm giving here all the delimiter fields terminated by comma. Okay, then I'm making select count star P choice from survey group by P choice. Okay, with respect to the program choice, I'm counting, then I'm displaying, I'm writing into results.csv file. Okay. So then insert the override directory results, making the survey from with respect to any choice. Okay, here making that from survey group by P choice. This also you can do it. Okay, you can use this command or you can use this command. That will go. So viewing the result. Okay, this is what you are writing the result to HTML file system. You are executing this SQL statement and writing the result of this SQL statement to HTML file system results. Okay. You want to view the results that's stored in HTML file system. So normal cat command you can make use of it. See here, normal cat results. So this result file will be stored in terms of this way only. So you can make it. Otherwise, you can go to that Hadoop GUI. You can go, then browser you can go and see http://localhost:5070. You put slash, automatically the file will be there. Okay, the results folder will be created there. This file will be there. You go and see. You can see the file, that's a data that the count. Okay, the ECE, how many people, CSE, ECE 10, CSE 15, mechanical 25, like that we will give. Okay, will be displaying. Okay, this what above the Hadoop you can install the Hive, and then you can execute the query as such in SQL. After executing the query result can be in HTML file system using overwrite. Okay, you want to view the file directly, you can use the cat command, as usual normal cat. Otherwise, you can go and see the result in browser. Okay. Any doubts? Any doubts?
No, ma'am.
Anybody is having doubt?
No, ma'am.
Yes? No. So it's
No,
very
ma'am.
difficult to do online. Yes? Okay.
There's no
It's
doubt, ma'am.
very, that takes time. It takes time to do hands-on, okay, through online. So that's why I made it as created as a screenshot. Then I shared with you people and explained. Okay, so you can make use of the PDF files, Hadoop installation PDF file and Hive installation PDF file. You send it. You try to install Hadoop. Above the Hadoop, you install Hive and execute the queries. And also you can execute the word count program using MapReduce model. Any more doubts? Dhanlakshmi ma'am?
Ma'am, I think no doubts for the participants, ma'am.
Okay. So shall we wind up the session?
Yes, ma'am.
Yeah. Thank you so much. Thank you for your patience. Okay. Sorry that I couldn't be able to do online.
It's fine, ma'am. The participants, right, can check your Word document, and whoever is interested, right, they can do the things on their own. Thanks for your session, and thanks for sparing your time to address all our participants. Thank you, ma'am.
Thank you, ma'am. Thank you for the opportunities given for me. Thank you, ma'am.
Thank you, ma'am. Thank you
Yes,
so much,
ma'am.
ma'am.
Yes, I will share all the details to the coordinator. Participants, please go through the documents and you try to install Hadoop and run on the overcome program, this MapReduce programming. Then you install Hive, then you execute the queries. You see how the files are stored in HDFS and how the files are, that's what, how can you put the files to HDFS and how can you get the files from HDFS. Okay, these things you work out. Okay, then only you can understand. If there is any doubts in that part, I can clarify. You can send through mail. Any doubts you can send through mail. I will clarify. Thank you all. Thank you. Thank you, Dalish ma'am.
Thank you, ma'am.
Yes, ma'am. Shall I leave?
Yes, ma'am. You can leave.
Yes, ma'am. Thank you.
Thank you, ma'am. Thank you so much.